One's a liar, Mom.
So now, we're going to graph the sine and cosine functions today. So the very first one we're going to start with is y equals sine of x. So if you have your pink sheets handy, we're going to look specifically at 4 specific points. The first one we're going to look at is pi over 2. The next one we're going to look at is pi. The next one we're going to look at is 3 pi over 2. Ah, there we go. Having trouble with the pen. And then we're going to look at 2 pi. Now, first of all, at pi over 2, where is it at?
90 degrees.
Actually, let's start with 0. At 0, where is it at?
0.
0.
Zero's at 0.
At pi over 2, what is the value of sine?
90.
Are you looking
Sine.
at your sheet? At pi over 2, what is the
1.
value of sine? The value of sine is 1. Okay. At pi, what is the value of sine?
0.
0. At 3 pi over 2, what is the value of sine?
-1.
Negative 1, okay. So negative 1. At 2 pi, what is the value of sine? It's the same as 0, which will be 0. So if you notice here, I start at 0, 0, go up, down, down, up. What do you think is going to happen at the next one?
Go
Up. What do you think is going to happen at the next one?
up. Down.
Okay.
Making like a zigzag.
Yeah, it's making
It's
like a
like a V.
zigzag. And so basically, now one of the things you need to be aware of, this is actually the graph of sine. It is a curve. Okay, it is not like the absolute value graph. The graph of sine does not have any edges that are corners. It's a curve. So when I see you graph these, I better not see you make any sharp turns, okay, right angles, anything. It's actually a curve. So that's what the curve looks like. So based on looking at that curve, we're going to make some judgments on what we learned in chapter 1. So first of all, what was the domain? Left to right. So what's the domain going to be? Negative infinity to infinity. Good. So there you go. There's the domain. What was the range? Negative 1 to positive 1. Very good. Now we're going to include those values because they were included. Continuity, what can you tell me about the graph? Was it continuous? Were there any breaks?
No.
No, so it was continuous for all x. Symmetry, was there any symmetry?
X-axis. Oh, X.
Let's go back and look symmetry.
Oh, no.
Origin. Who the origin is.
Okay, if we think about this, as I go backwards, I'm going to go down here, and then I'm going to go up. And so if you think about it, it does in fact have origin symmetry. Very good. Okay, symmetry is origin. And now this is something that we haven't talked about, oscillation, but it's something that's interesting about this graph. Oscillation, if you think about it, means you oscillate between two values. It's kind of like the pendulum motion. The pendulum oscillates. And so oscillation, does this graph oscillate? Yes, it goes between what two values? Between 1 and negative 1. Yep, like the heartbeat thing. Oscillates between those two values.
Which values are we looking at?
Yeah, the values that we're looking at real quick, there you go. We're looking at these values here.
Top and bottom.
Yep, the top and the bottom, because if you think about it, the graph just goes between those. When you think of oscillation, think about boundaries. So what does it never cross? It doesn't cross 1, doesn't cross negative 1. Okay, so there we go. We did sine. Now we're going to do cosine. Okay? So now here, let's go ahead and graph cosine. So once again, using your chart, we're going to start at 0, and then we're going to look at pi over 2. And then we're going to look at pi, and then we're going to look at 3 pi over 2, and then at 2 pi again.
Is 0 exact value is just all 0?
No. What is the cosine of 0?
0.
Wrong. What is the cosine of 0? 1. There we go. Cosine of pi over 2.
I will choose 0.
0, that is correct. Cosine of pi,
-1.
-1. What's cosine of 3 pi over 2?
0.
2 pi.
1.
1. What do you think is going to happen at the next one?
The same.
It's going to go down. So if I were to draw in the curve again, it's going to look real similar to sine, but it's not quite the same. What is the major difference between the cosine graph and the sine graph?
It declines further.
So obviously, what are you comparing first of all? You're comparing the first values. What do you notice about the value of cosine first? It starts at the high point. What do you know about sine? It starts at the middle point. Okay, so with this in mind, let's go ahead and fill in a few things. What's the domain of cosine going to be? Negative infinity to positive infinity. And you're going to notice there's a lot of similarities between the two. What's the range? -1 to +1. Continuity.
Yes.
So it is continuous for all x. Symmetry. What?
Where's the x-axis?
What?
That's origin symmetry?
So,
Y-axis.
Y-axis symmetry.
Y.
Okay, this one is y-axis symmetry. What about oscillation?
Yes?
Oscillates between
1 and -1.
1 and -1. Good. So now notice, all of this stuff we just got done going through with the exception of oscillation was the stuff we learned in chapter 1. So that's why we had to learn it, so that right now we understood the meanings of these. So let's go ahead and look at this. One period or one cycle of the sine and cosine function is. Now when I say one period or one cycle, I mean like one phase of the graph. So if I go back real quick and look at cosine, I want to look at one phase of the graph. When I say one phase, that means an area that does not repeat. How long would an area that not repeats be? Or what would it be between?
0 and 2 pi.
0 and 2 pi. Now, if you're wondering how does that occur, I'm going to start here at 0. I'm going to travel along the graph. So as I'm traveling along the graph, at what point do I start repeating my movements? And if you think about that, as I travel along the graph, I'm still doing something new until I get to this point right here. At this point, I start doing the same motion where I start high and then go down. And so one phase or one cycle of the graph is going to be a length of 2 pi. So, yep.
Do you have quick count right now?
Yes, I do.
Is there any time during the period?
Okay, so anyway, let's talk about sinusoid. A sinusoid is any transformation of a sine function, and so that's a definition that you need to understand. Okay, a sinusoid is any transformation of a sine function. And so this is the beauty of the sine function, is that everything we're going to look at today is nothing more than the sine function just transformed, just translated and moved. And so now what we're going to do is we're going to talk about something known as amplitude. Amplitude is the absolute value of A. Okay, and you're probably wondering, well, what is A? Well, that's why we need to write down the rest of it, because we do give you some examples of where A is used. The amplitude is half the distance between the maximum and the minimum values.
So it'd be
Half the
like
distance.
it comes down.
Right.
Zero.
Between the maximum and minimum values, I like to think of those as the highest and lowest points. I like to think of those as the highest and the lowest points. And so equations that we're going to need. First one here, y equals a sine x and y equals a cosine x. Now notice the amplitude is the number in front. Now you're probably wondering, why did we need the absolute value right here? There's a reason, because I could have a negative a down here, and it could be a negative number. Now what that negative does is that implies something else, and we will talk about that. Okay, so let's think back to the very first equations we looked at. We looked at y equals sine x and y equals cosine x. What was the highest point in sine? 1. What was the lowest point? Lowest point was -1. So what's the distance between those two? The distance is 2, right? So let's apply this definition. Half the distance between the maximum and minimum values. So half the distance of 2 is 1. And look at what number we have here. 1. Okay. So since there's not a number written there, it's implied to be 1. The amplitude of that very first function we looked at is 1. So let's go ahead and look at this. It says, describe how the graphs of y equals sine x and y equals 3 sine x are related. And so the first one we've already looked at, y equals sine x. So now what we're going to do is we're going to graph y equals 3 sine x. Now I don't want you to get too tied into your graphing calcs this time, okay, because we need to kind of learn how to graph these, and to be honest with you, it's probably faster by hand. Okay, if you remember, my point out here was 2 pi, and then I cut 2 pi into how many different parts? 4. So I cut it into half, which is pi, cut it into another half, which was pi over 2, and then this one was 3 pi over 2. My high point on sine x was what? 1. Okay, so here's 1, here's -1. So my sine graph is what I'm going to start by graphing first, and I'm going to go ahead and graph sine. So sine was 0, 0, then it went up to 1, back to 0, down to 1, and back here. So here is my sine graph. So that's the very first one. That's what I did right here. Now what I'm going to graph is y equals 3 sine x. So what does that 3 tell me?
It's
What was another name for that 3? Amplitude. So amplitude, that tells me how high up I'm going to go. So instead of going up 1 like I did before, I'm now going to go up to 3 and down to -3. So what that 3 tells me to do, first of all, I start here in the same starting point. Start at 0, 0. Instead of going up to 1, I'm now going to go up here. What do I do here at pi? Stay put. What do I do with the next one, 3 pi over 2? Down to -3. So do you see what the amplitude does? All the amplitude does is it like stretches it. It makes it go up higher. So there's your amplitude. That's it.
How can you just change it?
Just by putting a number, we multiply it by 3. So let's look at another one. Describe how the graphs of y equals cosine x and y equals 1/3 x are related. Okay? Describe how the graphs of y equals cosine x and y equals 1/3 x are related.
When you describe it, that's just drawing it.
Yeah, that's pretty much drawing it. So now, first of all, we've done cosine. So once again, we're going to start with the same thing. I know that cosine goes as high as 1, goes as low as -1. Here's 2 pi. Here's pi. Pi over 2. And there's 3 pi over 2. So first of all, let's start by graphing y equals cosine x. Tell me what I do. Start at 1, and then where do I go? Right? Yep. And so here is my pattern. So this is what the graph of cosine looks like. Now, look at the next one. It says, describe the graph of y equals 1/3 cosine x.
Just do a third of it.
So now, how high do I go up now?
1/3.
1/3. So instead of going up to 1, I'm going to go up to 1/3. Where do I go up pi over 2? 0. Where do I go up pi? -1/3. And then pi right here. So, like this. So there you go. So that's what the amplitude does. Questions on that? Now, I want you to think real quick. What would happen if, just for kids, y equals -1/3 cosine x.
Well, you need.
What do you think that negative's gonna do?
Goes around to the bottom right away.
Ah, so exactly right. So instead of starting up here at this point, for the negative, I'm going to start down here. So basically what the negative does is it reverses what you do. So instead of it starting at a high point, I'm going to start at a low point. Then my graph will be basically the opposite of what I've done.
So what if it's negative on sign when you start in 0?
Ah, we'll
You
get
just
back to
go
that.
down first then?
So the question is, what happens if it was negative at sign? Remember, sine started 0 and then it went up and like this. So what the negative does with that, the negative causes sine to, instead of going up first, it'll go down first. So basically you just reverse. So instead of going up, you go down. Okay, not too bad. The last thing we're going to talk about today, and then we're going to continue with this tomorrow too, is what is known as the period. Now the period, we briefly talked about this yesterday. Or not yesterday, earlier today, sorry. We briefly talked about this earlier today when I talked about the phase, or one cycle of the graph. The period is the distance between any two sets of repeating points on the graph. The distance between any two sets of repeating points on the graph. And so as you're writing that down, I want you to think back to when we talked about this. And does anybody remember what the period was for sine and cosine?
1 to -1.
Not the period, you're close. Remember the period, I had that and we filled in the little blank. We said one cycle of
It's
the
just
graph,
one. It's just one.
or one phase of the graph,
Pi.
was 2 pi.
Gosh dang, stupid.
So now what happens is, if you notice we've now extended our equations a little bit, I want you for right now to not worry so much about the C and the D. We haven't gotten that far. The C and the D does our left shifts and our up and down shifts. We're looking specifically at the B.
Didn't B just mean slow motion?
Okay. So B is what's going to tell us what the period is, because up until this point the period's been 2 pi. But now we're going to look at what happens when the period is not 2 pi. So notice how I find the period here. It is 2 pi divided by the absolute value of B. Okay, 2 pi divided by the absolute value of B. And so real quick, what class? What class? How many? So now it says to graph a sinusoidal function with a period other than 2 pi, 1, find the period, 2, divide the period by 4, and then add that value to the left end point of an interval with that length. So I need you to go ahead and write that down. And then we'll probably call it good for today. To graph a sinusoidal function with a period other than 2 pi. First step, you find the period. Divide the period by 4. Add that value to the left end point of an interval with that length. Now, as you're writing that down, I want you to think specifically on number 2. Why do you divide it by 4? But don't answer right now, because I know some of you are still writing that down. So why would you divide it by 4? So, okay, so why do you think you divide by 4?
The phases go every 4.
Because
phases.
exactly, the phases go every 4 points. And so if you remember, we started with 2 pi, we divided that into 4, and those are our key points. Okay, and so that's why you divide it by 4. So we're going to look at tomorrow what happens when you have a period other than 2 pi. The other thing we're also going to look at is what happens if we shift the graph to the left, up or down, etc. Okay, so if you want to go ahead and start, okay, we're going to continue with that tomorrow. Here's pages 264 and 265. We're going to look specifically at numbers 1 through 19. Okay? So 1 through 19.
This is what we can do today?
Yep. For the for the most part, you might not be able to do the ones with the periods. Okay, so with the change in periods, but go ahead and look at those.